Engaging minds creatively is our approach for learning. In this video, you will see how the questions related to a circle, triangle, and chords can be solved using the skills learned earlier, namely the Pythagorean theorem, the similar triangle, and the circle theorem. Let us see how it all comes together. I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. Let me thank all the viewers and subscribers for watching my videos and taking keen interest. We now have students in all the 5 continents. Our approach, engaging minds creatively, connects learning with its application. In this video, we will see how the concepts of Pythagorean theorem, similar triangles, and circle theorem can be combined together to solve many questions. We have 2 sets of questions before you. The very first set is the one in which we are going to use Pythagorean theorem and the circle theorem. The question here is, figure shows radius OP as a right bisector of the chord AB. Recall the concepts of right triangles and circle theorem to answer the following questions in this situation. So here are 4 questions for you. I'd like you to pause the video, answer these questions, and then look into my suggestions. This is the second set in which we have 4 more questions for you. The angle at A, angle OAM, is provided. This angle is 30 degrees in first 2 questions and 45 degrees in the next 2 questions. You are given information of other segments. You need to find the one specified. Now, once again, at this particular point, you have to use the concepts of Pythagorean theorem, similar triangles, and the properties of chord theorem. Have a good look at it, try to solve, and then look into my suggestions. Our approach, engaging minds creatively, connects learning. With this example, you have seen how the angles in triangles can be related with similar triangles and then to Pythagorean theorem and the circle theorem. Let us recall these special triangles. In the triangle 45, 90, 45, it is an isosceles right triangle. If the 2 legs are 1 unit each, then the hypotenuse is square root 2. Any triangle, right angle triangle, with 45 degrees will have the same ratio. The triangle 30, 60, 90 has the side ratio of 1 is to square root 3 is to 2, and it is maintained in similar right triangles. So for your reference, I'm writing down these values here. You can use similarity of triangles to answer the second set of questions. Now, this concept can be generalized and the skills learned can be transferred so that similar questions, many of them, can be solved. Now, let us look at the chord theorem. Perpendicular OM from center of the circle O to the chord AB bisects the chord. We need to prove BM equals to MA. The proof is straightforward. Join OA and OB. Now OA and OB are the two radii of the circle. OM is common. Therefore, the triangle OMA is congruent to triangle OMB. You recall hypotenuse leg theorem? Right. So we can say that BM is equal to MA. Hence, proved perpendicular from the center of the circle to the chord bisects the chord. Right? So that means BM is equal to MA. So when you connected O with B and A, you form these two right triangles which are congruent. In all our examples, that is the situation. So we know that BM equals to AM, and we also know that BM and AM when combined gives you AB. Therefore, AB is twice AM. Pythagorean theorem can be used to find the radius, which acts as a hypotenuse in this particular case, with OM and MA being the legs of the right triangle. So the radius OA square of that is equal to OM square plus AM square. That is what Pythagorean theorem is. That should help you in solving most of these questions. So combining the knowledge of special triangles with the Pythagorean theorem, we can solve both the sets. Let us begin with the very first set now. Here is the question once again for you. We have AM equals to 5 centimeters. The half bisected chord AB, which is 5 centimeter. You need to find AB. How will you find it? Simple as that, right? So AB will be twice AM. So to begin with, that is straightforward. And therefore, AB is 10 centimeters. Similarly, now you can solve the second question. In this question, we are given AM as 12 centimeters, but we need to find OM, OB, the radius, when OM is given to you. OB is the radius, right? So you can also find OA. It will be equal to OB. Use Pythagorean theorem. To begin with, these are straightforward calculations. However, let me remind you of one important concept, and that is Pythagorean triples. Do you remember what are Pythagorean triples? Recall. It is always good to recall and reconnect. That is the philosophy of engaging minds creatively. One of the triple is right before you. 3, 4, 5 is the most common and the simplest Pythagorean triangle. And we just saw 5, 12, 13. 12, 35, 37 is another triple. We might use it in the next example. Try to remember this and see how effective the solutions become if you remember the triples. Also look into my videos where we have explained how do we find Pythagorean triples. I hope you find it interesting. Keep connected. Now let's move on and take the next two questions of the first set.
The question here is OM is 12 centimeter. We are given O to M and AB is 70. A to B is 70. Find O to P, right? So this time O to P we have to find. So what is OP? Well, OP is the same as radius, correct? So it is also equal to OB or OA, right? Now we are given AB is 70. Since AB is 70, we can say that half of it will be one of these sides, right? So this side will be 35. That is, we can say BM is 35, right? So let's say that we are given AB equals to 70, and this gives you BM equals to half of 70, which is 35. Now we are given OM as 12. So this is 12 for us, right? So OM is 12. We need to find R basically, which is OB, right? So we can say radius. We'll write square first and then square root it, right? So the radius square in this case is what? 12 square plus 35 square, correct? And R will be square root of 12 square plus 35 square, right? You can use your calculator and write down your answer. Well, the answer, as you know, is 37 centimeters, right? Correct? So you can definitely use the calculator. This is another Pythagorean triple, which I shared with you earlier. You get the idea. So using Pythagorean triples, we can very easily find the solutions in no time. Otherwise, you need to use the calculator. Now, it is important that in some test papers, calculator is not allowed. So this is beneficial. Now let's take the fourth question. So that was our question number 3. Now we'll take question number 4 from the first set of questions. This time we are given OP. So OP is given to us as 37, which is also the radius of the circle. AB is 70. So we are given A to B, which is the whole length, as 70. Find O to M. This time we have to find what OM is. Well, clearly, half of this is BM, right? So let's find what BM is, which is half of AB. So it is half of 35, just as we did earlier, half of 70, which is 35, correct? And we know that the radius here is given to us as 37. So we know that OB is equal to radius, which is equal to 37. And therefore, we can find what OM is. OM, being a shorter side in a right angle triangle, is going to be 37 square minus 35 square square root. And what you get is basically 12. Correct? So that is how we can actually solve these questions, right? And the units, of course, is centimeters. Correct? So I think it is absolutely clear how we do the first part, which is involving the right angle triangles within this circle. Now let's take the second set of questions, which involves the angle. Now remember, We are not talking about the special triangles, right? Okay, so the question here is, figure shows radius OP as a right bisector of the chord AB, right? So this is the radius which is right bisector. Recall the concepts of special triangles and circle theorem to answer the following questions in this situation. Perfect. Question number 1. Measurement of angle OAB is 30 degrees. So we are given this angle as 30 degrees this time. B to M is square root of 3. B to M is given to us as square root of 3. You have to find what OM is. Perfect. You can pause the video, answer the question. Now, let's look into its solution. So let's do this question on a fresh page. We are given that the angle OAB, this angle, is 30 degrees, right? So that means I'm looking into a triangle which is 30, 60, 90. Sometimes I prefer to draw the triangle in this fashion. So we know that if this is 60 degrees and that is 30 degrees and this is 90 degrees, then the sides ratio is 1, 2 and square root 3. Now in this, we are given the measurement of angle OAB as 30 degrees. So we are given this particular angle. Do you see that? Side BM is square root 3. Now when I say that BM is square root 3, that also means that AM is square root 3 and the total length will be 2 square root 3, right? We have to find the value of O2M, but anyway. So this is square root 3 for us. We are given one of the sides. This angle is given to us, which is same as that. And this is also 30 degrees, correct? Since this is an isosceles triangle. Perfect. Now we need to find what O to M is. Now see, from proportions, we can actually solve this question. You do not need trigonometry for this particular application. So, if the side adjacent to 30 is square root 3, the opposite side is 1. You see that? The opposite side is 1. And therefore, we can say from similar triangles that OM is equal to 1. Does it make sense? So look here at the triangle once again. So from this triangle, we can have the corresponding result. So the ratio of OM, the ratio of, you can say, the ratio of OM to BM should be, in this case, if I consider this, OM is opposite to 30, 1 over square root 3, correct? So if I'm given BM as square root 3, then OM has to be 1, right? So straight correspondence give us the right answer. Perfect. Now let's look into this second question. In this case, once again, we are given this angle as 30 degrees. Now OP is given to us as 8. So OP is 8. That means the radius is 8. Find OM this time. So this time we are given the hypotenuse, right? We are given the hypotenuse, right? And the side opposite. So we are given the opposite side and we are given the hypotenuse. Do you see that part? So the ratios will be constant, right? Comparing with this, and we're talking about the angle 30, right? So from here, the opposite side is 1 and the hypotenuse is 2. Do you see that? So the ratios of opposite to hypotenuse is constant. So in this case, OM over OB should be equal to, if you're looking from 30 degrees, 1 over square root. Now this time we are given the measurement as 45 degrees. So when I say 45 degrees, think about an isosceles triangle, right? So now measurement of angle OAB, so this angle is given to us as 45 degrees. Find AB means we have to find this length. Oh, AB is also given. So measurement of angle OAB is 45 and AB is 12 centimeter full and find OM. You have to find OM, right? That is what you need to find. Okay. So since we know AB, we can find what A to M is, right? So A to M is half of AB, right? So which is half of 12 and that gives you 6. And we know it is 45 degrees. So 45 degrees means it's an isosceles triangle. So the two sides should be equal, right? So O to M should be equal to A to M and both should be 6 centimeters in this particular case. Since we have isosceles right triangle. Is that clear to you? That brings us to the last question here, where the measurement is given to us for the angle A, OAB, that is 45 degrees. O2P radius is given to us as 4 square root 2, right? And we need to find AB. Well, what we can do here is we can find what AM is first, right? Now, let us find what AM is. Now, what we know from here that the ratio of the sides are 1 over square root 2, right? So 1 over square root 2 should be equal to what we need to find, which is AM over the given side 4 square root 2, right? So we're looking into this small triangle, correct? And so from here we can find what AM is. So if you cross multiply, we get AM equals to 4 units, right? If I know that AM is 4 units, in that case, now we need to find what AB is. AB is equal to 2 times AM, right? So which is 2 times 4 and that is equal to 8 centimeters. Do you see that? So that is how we can actually solve this particular question. So that helps us to solve all the questions which we thought about. And what did we learn? We learned how do we connect different concepts when applied in a given situation. So we connected with the angles, with the triangles, and with the circles and the properties of circles to solve many different questions in this particular exercise. I hope that helps you to review all these concepts. Thanks for your time and all the best.